Well, friends, today we're going to be talking about space travel. And we're going to go through our introduction. We're going to talk about the history of space travel. We're going to talk about the purpose or why we go to space. Then we're going to go over our activities and some resources. So as an introduction, you guys all know this part. I'm Megan and I'm Aiden and Lizzie's mom. And I don't think we have any new friends joining today, so I won't go into it too much more. But I thought that this was a really interesting topic and I got some suggestions from you guys to do this too. So that's why we're discussing it today. And you guys might have watched this over the weekend. Does this look familiar?
Yeah.
Yeah, so this is Bob and Doug in the SpaceX and NASA kind of co-launch of the Dragon. And the kids and I watched this weekend. And so that's kind of what started this topic. So I thought we would talk a little bit about the history of going to space, and then we can talk about this particular launch as well. So as far as the history, space travel really started about 70 years ago. So in the 1940s, this is, quite a long time ago, but maybe your grandparents might remember this. The first thing really was the V2 rocket, and that was launched by the Germans during World War II, and it was the first man-made object that went really high up into space, so 100 kilometers. And then in 1946, we captured some of the first pictures from space. And you can see this kind of old-timey looking rocket in the picture there is the V2 rocket. And then in the 1950s, the first kind of life forms were sent into space. So the first dogs, Dezik and Saigon, those are really hard to say for me. They were sent from a Soviet rocket or Russian rocket. And these dogs went into space, which is pretty cool. And then the Soviet Union also launched the first satellite into orbit in the 1950s. And because I know you guys will all want to see this, here are the two first space dogs in their little space harnesses and things. And that's a picture of them.
One looks like a corgi.
Yeah, it kind of does. And the other one looks like maybe a border collie. And then the other thing about this, I said on the previous slide that the first satellite went into orbit, and that was called Sputnik 1. And it transmitted for about 22 days. And the picture on the right here is Sputnik 1. And this is what really started the race to get into space. So the space race was mostly between the United States and the Soviet Union.
Hi, Oliver. Come watch the space singer, dude.
Which is now Russia. And so it was basically a big kind of competition between the United States and Russia during this time to see who could get into space and do more things in space faster. And so then in the 1960s, things started to kind of speed up. Right? So we're doing more research. We had sent dogs into space. And then the US in 1961 launched the first chimpanzee into space that performed some tasks while they were there and also survived the trip. And then following that, the USSR or the Soviets. Yeah, did you have a question, Olivia?
Did the dogs die? Did they make it back?
I think the dogs might have died. That's really sad. So part of the issue with some of this early space exploration is that people had different ideas about kind of the value of animals in science at this time. And so one of my jobs right now at Scientist is to help people with animal welfare, which means how we take care of animals and how we treat them. And so we always try to do our best to use as few animals in research as possible and to make sure that they're humanely treated or treated nicely as much as possible so they get all the things that they need and they're not scared or in pain. And people weren't quite as strict about this back in the 50s and 60s when they were doing this research. So luckily for this first chimp, though, it survived and managed to come home, which is good. And then the USSR right after that launched the first human into space. And he also managed to come back. So, and then a little later in the 60s, somebody did the first spacewalk. So they actually went outside of their vehicle and walked around in space. And here's a picture of the chimp. I think his name was Ham, it said. And this is him in kind of his little, it almost looks like a funny baby car seat that he used to go to space. And then this other picture is of Yuri Gagarin, who did that first spacewalk. So you can see he's kind of untethered outside of the space shuttle. And then later in the 1960s, a couple other really interesting things happened. There was a first landing on another world. So the first landing on the moon, and the first images came from the surface so that we could research those images. And then during that time, also 2 spacecraft managed to dock together, which is it doesn't sound very exciting, but it's actually a really important milestone, because if you think about it, things traveling in space are moving very fast, and they're, moving all around, and they have to manage to dock with a very specific accuracy, right? So they're like super complicated puzzle pieces that have to fit together at the right time and in exactly the right way. So it's kind of a big deal that they managed to meet up. And that's actually important for future research, and for being able to have things in space that stay there, and then that we go to connect with back and forth like a hub. And that'll come up a little bit later. And then finally, towards the end of the 1960s, we had the first human walking on the moon, and that was during the Apollo 11 mission. And that was a NASA mission, so from the United States. And here's a picture of the moon landing, and you can see they're putting their flag there on the moon. So that was really kind of the culmination of that big space race that we talked about before, kind of the end of the space race, where we actually got the first human on the moon. And it doesn't mean that we stopped trying to do anything with space after that, but it means this was kind of the first big marker for success of that program. So then moving on, in the 1970s, there was a lot of focus on going even farther than the moon. So the USSR, again, was doing some launches, and they conducted the first soft landing, or kind of, intentional landing, where it doesn't just like slam into something, on another planet. And they landed a probe on Venus, which is pretty cool. And then later in the 70s, something really exciting happened. Voyager 1 and Voyager 2 were launched. And these, Olivia.
People have been to Venus?
No, so there wasn't a person on that. That was an unmanned spacecraft.
Oh, it was a car.
Kind of like a car without people in it. Yeah.
What is Venus again?
It's a planet. So it's a neighbor of ours, basically, a neighbor of Earth. And so later in the 1970s, though, the Voyager 1 and 2 both launched. And this was really exciting because they were going on kind of this huge, huge mission and huge journey to the outer planets. So the planets that are past Earth and past that kind of asteroid belt and like way, way, way far away, they were going out there. Inez or Carmen, did you have a question?
Yes, we just came in. Who won?
The
Just
race? Kind of the United States. So we managed to land people on the moon first, and that was kind of the big point for the space race, but then lots of research has continued since then. Okay, so I want to show you guys, this is one of the, this is Voyager 2, but Voyager 1 and 2 were kind of twin spacecraft, right? So they were both basically the same, but they were launched on these big journeys, and they've been out in outer space for more than 40 years at this point. So they are way, way farther away from Earth and the sun than even Pluto. So they're out past our solar system. And in 2012, the first Voyager went into interstellar space, which means it's the region between all of the stars. So the point, and then Voyager 2 made it there in 2018, so really recently. So these probes or spacecraft are still exploring and still traveling. They don't have people on them, obviously. But what they do is send a lot of data back to us. So there's a kind of scientific network called the Deep Space Network, and they're able to send scientific information back to us about like pressure and temperature and movement and things like that. And they send pictures and things too. So we can really learn more about these parts of space that are so, so, so far away that there's really not any hope right now of people ever getting there. And that was in the 70s, but those two spacecraft are still traveling and sending back information today, which is super cool. And then in the 80s, we launched a first space shuttle that was reusable. So it used to be that we launched stuff into space and it would sometimes come back, but then it was done. It was kind of like a very, very expensive disposable car. right? And then with the space shuttle, we started being able to use these reusable, kind of like an airplane, how you would use an airplane over and over again. And also in the 80s, right before I was born, actually in 1986, the Mir space station was basically ready to go. So the Mir space station is pretty cool. This is the Mir, and it in Russian means peace or world. And it's a space station that operated kind of floating around the Earth from 1986 to 2001. And it was modular, which means it was different pieces kind of ready to go, but fitted together, almost like you would fit together Legos. So they sent different kind of chunks of this space station up into space and then put them together and constructed them. And it was bigger than anything else that we had ever put into space before. But so Mir operated for quite a long time, and a lot of important research was done on the Mir. Then in the 90s, we also launched the Hubble Space Telescope, and I bet that sounds pretty familiar to some of you guys, the Hubble. So that is kind of still floating around out there doing cool stuff. And we also had the longest space flight record was set in 1995. So this cosmonaut from Russia was in space for over a year. And that was pretty much unheard of at that point, and it still hasn't been broken. Nobody's been in space for that long continuously since then. And then later in the 90s, as the Mir space station was starting to age, we started construction on the International Space Station, or the ISS. So I want to show you a picture. Here's the Hubble telescope. And the Hubble has been floating around out there for about 30 years now, and sending back amazing, amazing photos. And you can check them out on NASA or any of the European Space Agency sites because it's kind of a joint project. But here's a couple pictures that the Hubble has sent back. So you can see, check out, here's Jupiter and a bunch of other planets and nebulas and stars forming and just amazing things. And so when the Hubble is sending back these images, scientists can use them to learn about the formation of stars and kind of what's going on in space. And the Hubble is still traveling and sending us really cool pictures.
There's a thing on NASA on the website where you can find a picture that the Hubble saw on your birthday.
That's really cool. I didn't know that. I'll have to check that out. Although, yeah, I suppose if it's going for 30 years, hopefully everybody on the call is able to get a picture. Okay, so then in the 2000s, which is pretty recent, we sent this first spacecraft went to orbit an asteroid. So before we were orbiting planets, right? Or orbiting Earth, but at this point we were wanting to learn more about asteroids. So the first of those actually came out. And then in 2005, something super cool happened. And I had to look up how to say in this name because it's Dutch. And I think it's the Huygens probe, from what I could understand. And it performed the first soft landing beyond Mars on Titan, which is pretty cool. So this is a image of what we kind of think that looked like. And the Huygens probe landed on Saturn's largest moon, so Titan. And this was a cooperative project that was between NASA and the ESA, or the European Space Agency. So kind of joint. Carmen and Inez, do you have a question?
Who won the homework?
Oh, who won the homework? Olivia did. Okay, so this probe went into the atmosphere of Titan, and that was in 2005. And what it did was send us a bunch of information back about the atmosphere. So it was on the surface for, I think, an hour and 10 minutes that it sent data from, but it took it about 2.5 hours to kind of slowly descend onto the surface because we didn't want to crash land, right? And it sent back a bunch of data and a bunch of images. And so we're able to know a lot more about the consistency of the ground and what it's made of and what it looks like that we never would have been able to find out before. And then coming into this last decade, there was a bunch of new advances. So one of them was that the final flight of the Space Shuttle Atlantis happened, and that was kind of the end of our Space Shuttle program. So that was really the last time that the United States was sending humans into space. So we might have hitched a ride on other spacecraft with other countries, but we didn't really launch our own space shuttles after that. And lettuce, actually, this is pretty cool. Lettuce was first grown and eaten in space. So this is the first time that we grew a plant and then ate it while we were in space. And part of the reason we were able to do that is because a lot of research has been going on into horticulture in zero gravity and figuring out how that works. And that's one of the purposes of space travel, but we'll get into that a little bit later. And then finally, here's the Space Shuttle Atlantis. So on its last flight, Brandon?
Can potatoes grow on Mars?
Could they grow on Mars? Maybe. I think they would need to have oxygen.
There's no gravity because they can hold themselves down because the potato is underground.
Yeah, I guess if you buried it, you could, but I think it would need oxygen and water. And I don't think there's enough water on Mars for a potato to successfully grow.
I have the Lego set of that ship. I got it a long time ago.
Cool.
And I actually, it had that big middle part, the actual space shuttle, and then it had those 3 big rocket pieces.
Yes,
that
you're
could
right.
get. It was a couple of years ago that I
Yeah.
had it.
So that's a good point, Aiden, is that the rockets that the shuttle is kind of attached to here, the rockets help it boost into space, but then those are detached. Yep. And so then it's just the space shuttle that comes
You can
back.
do that with the Lego set. You can detach everything from the
Mm-hmm.
the
from the
actual
main body.
spaceship, and there's like a little probe that goes out from it, like a little satellite thing.
Cool.
I
Okay.
saw this thing, a documentary, I think,
Mhm.
and they're gonna try to send something to orbit the sun. So it needs to have a lot of
Heat resistant.
Yeah, it would definitely need a lot of heat shields, right? Because you don't want to melt everything before you get information back. That's pretty cool.
I also watched the movie Apollo 13.
Aiden and Lizzie like that movie too. So then going into the 2020s, you guys might have seen this weekend. This is the Dragon spacecraft that launched. And it launched from Florida and had crews in Houston or in Texas, and then outside of Houston, I guess, and then in California that were helping coordinate the launch. And it's capable, the Dragon, of carrying up to 7 passengers to and from, but it carried 2 this time. And so it can also take significant amounts of cargo, which is a pretty big deal. And it's also thought that soon it will become the first private spacecraft to take humans to the space station. And that's exactly what happened on Saturday. So private meaning it wasn't built by the government. So it was actually built by SpaceX, and it was a joint initiative to actually get it to launch. And I'm going to show you a little bit about the Dragon now. So this is from the SpaceX website, and you can see there's a picture of the Dragon here. And they've launched it a couple other times, 22 times, and visited the International Space Station with cargo, but this was the first time it was carrying humans. And so this time, you guys might have seen, it took Bob and Doug to space, and they managed to dock successfully with the International Space Station. And so they also have cargo kind of in there with them. But here's what it looks like, which is pretty cool. It looks pretty futuristic, I think. And it's actually not as big as I thought. It's about 26 feet by 13 feet in diameter. And I, for some reason, pictured it being a lot bigger.
Yeah, it's pretty small.
Yeah, but also this doesn't include the rocket part, right? So this is just kind of the actual craft that has people and cargo in it. And let's see, there's the trunk part, and that kind of supports the aircraft, and that's where all the cargo goes. So the people go in kind of the top part, and then there's basically the trunk of the car, right, that stores the cargo. And this is the part where Bob and Doug were hanging out in the capsule. And if you saw, they kind of opened up the tip of the capsule and were able to dock with the International Space Station and come out. So it was pretty exciting. You can see the seats here, and this is where Bob and Doug were hanging out in their cool space suits. And they also had pretty fancy spacesuits. They didn't look quite like this, but here's the engine, which I think is pretty interesting looking. It's not what I would picture an engine to be like, but it's got a lot of these thrusters that help keep the spacecraft going in certain directions. Because as you can imagine, you can't just launch into space and then let yourself cruise to wherever, especially if you have to make the puzzle pieces fit so specifically. So these thrusters kind of help push the aircraft or spacecraft into different directions at like little increments. And then it also has a parachute system. So when it comes back to Earth, after it enters into our atmosphere, these parachutes will deploy to help slow them down. And then the idea is that they'll kind of land in water and be able to be taken out. So pretty cool. If you guys want to come and check out this website, I will make sure I send a link to this to you. Yes, Brandon?
The rest of the rocket.
The rest of the rocket is detached while it's in space, and they're just kind of space junk then floating around.
Mm-hmm. So the dragon, then how do people land back safely into Earth? Do they build another rocket?
No, there's usually enough fuel left in what they have to help them enter Earth's atmosphere, and then at that point, gravity is going to take over, right, and pull them back towards the Earth.
Yeah.
So we need a lot of force to exit Earth's gravity, but coming back in, the Earth is like, oh, hey, and kind of gravity pulls you down.
Mhm.
Carmen and Inez, did you have a question?
What would happen if they don't have enough fuel for coming back? I think they would just die floating around the space.
Unfortunately, that's probably what would happen unless they could somehow redock with the space station and wait for someone to bring them more fuel. But I'm not sure that's possible.
Yeah.
Because there are two different sides to the International Space Station. There's like the Russian side and the American side, and they can both dock at different sides. So maybe someone could come bring them enough, but I'm not sure.
If you get stuck in space without a spacesuit, then your lungs will collapse and you'll freeze.
Yep. Yeah, you'd be out of luck.
It will pop.
Yep. Because of the pressures and the lack of like oxygen in any atmosphere and stuff, you would freeze pretty quickly.
Why would you freeze? Because
It's so cold in space. Okay, so why do we go to space? I just told you all these, like, the history of it, but why do we actually go there? And there's a lot of different reasons. One of them is for advancing scientific research, and that's the one I kind of am going to focus on and that we focused on today. But another one is national prestige, so kind of looking good as a country and being impressive, like we talked about with the space race between the USSR and the United States. Another one is actually for uniting different nations. So it can be about trying to look better than your neighbors, but it can also be about working really well with your neighbors. Olivia, did you have a question? Okay. It can also, we think, help ensure the survival of humanity. So maybe you guys have seen the movie WALL-E, where we kind of destroy the Earth and then have to go live somewhere else. And it's thought that if people do need to leave the Earth at some time, maybe exploring space can be helpful to find somewhere else to colonize. And then finally, for developing military and strategic advantages. So it's thought by some people that maybe the moon could be some sort of strategic base, or also that it can be a strategic advantage. A strategy is kind of like long-term planning. And it's thought that the advantages to having all of that scientific knowledge could be really big. So some of the research that goes on in space is actually pretty intensive and complicated. It's not just little experiments to see like if plants will grow. There's actually been a lot of research on Parkinson's disease in space. And Parkinson's is a degenerative nerve disorder. So what it means is it makes your nerves kind of break down over time. And that causes some of the hormone and chemical signals in your brain not to work quite as well. And people that have Parkinson's, there's about 10 million people living with Parkinson's, and they have kind of tremors and stiffness and loss of balance. And one of the most famous people that have Parkinson's is Michael J. Fox, and he has a foundation that raises money to study Parkinson's, and working with that foundation and the International Space Station, they've been doing research to target a protein that is produced and could possibly involve Parkinson's. So I know that was kind of complicated, but the thought is that because there's no gravity in space and on the International Space Station, that they can grow these samples a lot more quickly and a lot more uniformly, which means same. So they can be more consistent or similar across all the replicates or copies of the experiment that they're doing.
So the number of ones that go wrong will be reduced.
Yes, that's kind of the hope. And so they're thinking that it'll make it easier to study than when they're back on Earth. So they're growing them in this environment, and then when they bring them back to Earth, it'll hopefully work better for all of the imaging and pictures we want to take of those proteins. And this experiment was started in 2017 on the International Space Station. And I think that's a really interesting one. And there's also some experiments on the ISS, or International Space Station, around recycling. So there was a kind of startup company a few years ago that sent the first 3D printer into space. And what that did was allowed astronauts to basically make their own parts. So if something broke, they don't have to make the trip back to Earth to like pick up something new and come back. You know, it's not as easy for us as going to the hardware store. Having to go back from the space station to Earth takes a lot of time and energy, right? So if they have a 3D printer, they can just print new parts for themselves, which is really cool. And this other device that's on here is called a refabricator. And what that means is that it's a 3D printer and a recycler in one. So they can take all the plastic waste that they have from their broken parts, and they can put it into this machine, and it'll turn that plastic into the new material for the new part. So basically they're taking like it's kind of like if you took a broken tool and put it in a machine that melted that tool down and then made a new copy of it that wasn't broken, which is pretty cool, because if you can think about it, they probably don't have a lot of space for trash on the International Space Station, right? They have to be really careful about how much room they have. And so this way they can not only get their own repairs done quickly and replace things, but they can also recycle. Other experiments going on have to do with health in general. So space offers us a lot of possibilities to study health problems related to immobility, which means the inability to move. So if you were paralyzed, or maybe you're on bed rest for a long time, or maybe you're really elderly and you don't have a lot of muscle tone anymore, there's a lot of things that happen to your body in that case. And people being in space, because there's zero gravity, allows us to learn more about that specifically. And so this guy is laying in kind of this funny bed thing that is supposed to kind of help with some bed rest issues, and we can kind of study how astronauts live in space and what happens to their bodies, and come up with ways to keep those bad things from happening even though they're in space for a long time. So if you think about it, if you're up in space floating around for a year and your muscles don't have to work very hard to do anything, right? Like you don't have to work hard to walk or to move things. What do you think might happen when you landed back on Earth and tried to get up and walk?
You can't walk as well.
Yeah, you might be super weak because your muscles are really out of practice, right? They're not even used to holding up your body weight. So there are a lot of things that astronauts have to do to try to keep their muscles in shape while they're in space. And that is helping us learn more about what happens to people that are on bed rest. And so it's also allowing us to create tools for monitoring health, because doctors have to monitor astronauts' health from long distances, right? So we're getting a lot of new tools that way as well. Another reason that we do it is just for exploration, right? The same reason that we explore jungles in the deep sea. We want to learn more about what's around us and maybe plant our flag, be the first person there. It's kind of a exciting thing. And then also for long-term survival. So this is someone's rendering, or what they imagine it would look like to have a habitat on another planet, specifically on Earth. So this would be
Megan,
yes, Rhea.
how do we brush teeth in space?
Oh, that's a super good question. So I believe what they do is they use these little kind of dry capsules that they chew on, and then they brush their teeth, because you wouldn't want to have water, right? You don't want to spit all your toothpaste water out, because then it would just kind of be a big cloud of toothpaste water floating around in space inside the space station. That'd be kind of gross.
Yeah.
And how would you eat in space, Megan?
How do they eat in space? So they actually have food that's kind of prepared for them in little packets and things that can heat themselves up. And it hopefully then doesn't spread that food everywhere. So there's only certain things they can really eat in space, because if food is really like dusty or messy, they don't want it to float all over and get everywhere.
How do they go to the bathroom in space?
They
Yeah.
go in a bag.
Yeah, they go in a bag, or they have like a special thing kind of connected to their spacesuit that's like an extra fancy diaper. And when they go in a bag in space, actually this is kind of gross, but the space station actually can recycle their urine or their pee and make it into drinkable water for them to reuse. So hopefully if we colonize the moon and everything else, we would be able to maybe bring some water or somehow manufacture water, but it also might be that we're recycling our waste products to get water back, which, to be fair, we do right now, right? So when you flush the toilet and it goes to the waste factory or the waste management place and gets all cleaned up, and all the water that we have on Earth right now is all the water that we've ever had on Earth. So McKenna, you might be drinking old dinosaur pee right now and not even know it. Okay, so guys, we're gonna talk about our activities now. For little kids, you can draw a spacecraft or a space station. You can build your own space station, whether that's out of Legos or food or anything you want. You can build it out of anything, or you can color one of these coloring pages from NASA from the link. Big kids can draw a spacecraft and label important parts. You can make a comic about space exploration, or you can write some sentences about the history of space travel. And then middle schoolers can draw and label a spacecraft docking with the ISS. You can write a paragraph about the history of exploration, or you can create a comic about the SpaceX Dragon launch that just happened. And you can include Bob and Doug, our intrepid explorers, if you would like. And then, of course, you guys can email your homework to me, and I'll put you in a drawing to win the $10 Amazon gift card, which Olivia won today. And then there's some more resources here